Hi, in this video, we'll walk through the solution for Preppin Data 2022, week 28 in Alteryx and Python. We'll start out by looking at the challenge requirements, and then we'll look at the Alteryx solution and then the Python solution. So if you just want to skip to the Python part, you can use the chapters below. So this challenge was super fun, at least to me. So this is the second in a series of 4 beginner level challenges for the month of July, and they're going to focus on data prep fundamentals. So last week in week 27, we did some string parsing, we did some simple formula, a simple formula, and then we did some aggregation. So this week we are finding missing values. So our input this week is a single file. It's a CSV file, and it's the exact same file we worked with last week. So if you did week 27, you will be familiar with this file. So we've got the sale date, information about the order, when it happened, the product that was sold, and the store that sold it. But for this particular challenge, all we really care about is that sale date column. So that's going to be really the only thing we need this week. So we need to figure out which days in this range did not have any sales. So we have a list of the sales that actually happened, but we have to figure out which dates did not have any sales. And then we just need to get the corresponding day of the week and count them up by day of the week. So this is, again, the Chin and Beard Suds Company, which is a fictitious soap retailer in the UK that the Preppin Data team have made up to give us some challenges over the years. And so for the Chin and Beard Suds Company, it looks like Thursdays and Sundays are the most common days that do not have any sales. I don't know the business context behind that, but we'll just go with it and try to match this output. So heading on into Alteryx. We'll start by inputting our data with an input data tool, and then we'll navigate to that file. And this is, again, the same file that we used last week for week 27. So our sale date right now is a string and not an actual date type. So we need to convert that. There are a variety of ways you can do that in Alteryx. You can use the datetime parse tool. You could use a standard formula tool. I'm going to do something a little weird, and I like to use the multi-field formula tool for this. So the multi-field formula tool is designed to apply a formula to multiple columns of your data set. It just applies that same formula across whatever columns you choose. So in my case, I'm only going to apply it to the one column. And so I'm going to choose text fields, and I'm going to choose my sale date field. So normally you'd be checking multiple fields here, or maybe all of them, but in our case, we're just going to use the one. I'm going to uncheck this copy output fields and add, and then I'm going to check this change output type, and I'm going to change it to date. And so this is the beauty of the multi-field formula tool, because you can actually change the field type and keep the original name. So you can change it and do the parsing and not end up with an extra column. I always struggle to remember when I have the original column called sale date, and then, if I use one of the parsing tools, I have like sale date out, and then I have to remember which one I actually need to use, or I have to use a select tool to get rid of the extra field or rename the original field. But with multi-field formula, I can just do all of this in one tool and not have extra fields that I have to try to remember which one's right. So as someone who's a little bit obsessive about having a tidy workflow, I love this particular method. All right, so the expression I'm going to use is called datetime parse. And so what datetime parse does is it takes a string and converts it to a datetime based on a specifier string that you give it. So the field that I'm going to parse is my sale date field, and I could certainly input that directly, or since it's the multi-field formula tool, it's designed to work on multiple fields. We just use this current field placeholder. So in our case, current field always corresponds to sale date. And then we add our specifier string. So I'm going to leave that blank for now, and I'm going to run the workflow. So for parsing, I like to go into my actual data and just take an example to use as a template. So I'm just going to take one of the dates from my actual data and put it in here so I can overwrite it with the specifiers. So the first number, in this case 14, that represents the day of the month. So I'm going to replace that with the specifier %d. Then the next one is the month. So I'm going to replace that with %m. And then finally, we have the 4-digit year. And so I'm going to replace that with the specifier %y. So these specifiers are just kind of placeholders. This is kind of similar to regular expressions, but we're adding placeholders here to tell Alteryx where to find different things in the pattern. So where to find the different parts of the date in the pattern. And I will put a link in the description to a really helpful page in Alteryx Help that lists all the specifiers. So that's a really good one to bookmark if you ever work with dates. I work with dates a lot in my job, so I have a lot of them memorized, but I definitely have that one bookmarked for handy reference because it's super helpful. Because I'm always, it took me a really long time to remember whether or not month was lowercase or uppercase m. So that list will be really handy for that. So what we're doing is we're just telling Alteryx the first number you come across before the slash is going to be the day of the month. And then the second number you come across, the part that's between the slashes, that's going to be the month of the year. And then after the last slash, but before the space, you should have the 4-digit year. And I could certainly add specifiers for the hour, minute, and second here, but I'm just going to have Alteryx treat this like a string. Every single one of my input dates have just zeros, so we're just telling Alteryx after you hit the year, the next thing you're going to come upon is a space and then 00 colon 00 colon 00, and you can ignore that because that doesn't have any specifiers in it. All right, so let's annotate that and run it so we can see what it is. So now in our results window, we can see that the sale date indeed looks like it's parsed to a date, and we can check the metadata and see that indeed the type is date. So we're good to go on that. So now we have our dates that sales actually happened. So now we need to figure out all of the possible dates so we can figure out which ones did not have sales. So I'll use a summarize tool to take the min and max of my sale date. And then I'm going to go over to the preparation menu, and I'm going to grab the generate rows tool. And so generate rows is going to create rows for some conditions that we specify. So what we need here is we need a list of all the days between the min and the max date. And then we'll see which ones of those are not in the actual sales. So if you've ever used a while loop in programming, the generate rows tool works a lot like that. It's just going to keep generating rows while a condition is true. So we're going to create a new field, and then we're going to call it sale date. And we're going to set the type to date. And it's important here that the field type that we used for our actual sale date and the field that we use here are the same type. Because we're going to use an Alteryx join later, and the join tool needs you to have both types the same. So they can either both be dates or they can both be date times, but you can't join a date to a date time. So for us, we're just using date for both of them. All right, so we're creating a new field called sale date, and we made the type of our new field date, and then we'll set our initialization expression. So I'm going to click the ellipsis, and I'm going to remove the one that's there by default and replace it with min sale date. And you can certainly type directly into these boxes in the configuration window. I just like to use the ellipsis because that way I can double click on the field name and not have to remember how it's spelled. So the next we have our condition expression. So I'm going to again hit the ellipsis button and delete what's there by default. And so my condition, so this is like the while loop. We're going to keep generating rows while this condition is true. So my condition is where the sale date is less than or equal to the max sale date. So I'm going to start with the min sale date, and I'm just going to keep on generating rows until this is no longer true. So while this is true, I'm going to keep generating rows. And then my loop expression, again, I'm going to hit the ellipsis down here and delete the default. And I'm going to use date time add. I'm going to take my new field, which is sale date, and I'm going to add 1 day. So I'm going to start with the minimum sale date, and then I'm going to keep generating rows by adding 1 day until this condition is no longer true. So as long as sale date is less than or equal to max sale date, then I'm going to add a row for that. All right, so let's annotate and run the workflow so we can see what that did. All right, so you can see now I have 365 records, and they start on January 1st, 2022, which is the min sale date. And I have 1 record for every day in the year all the way down to December 31st, which is the max sale date. All right, so now I've got my sales that did happen, and then I have all possible days. So now we just need to join them together so we can figure out what fell out of the join. All right, we're going to join on the sale date. And so the Alteryx join tool has 3 outputs: left, join, and right. So the join output does exactly what you think it does. It outputs any records where the left side joined to the right side, whereas the left and right outputs show us any records that fell out of the join. So left would show us any records that were in the left input, but not in the right. And then right is vice versa. It shows us anything in the right input that is not in the left. So in our case, our left output should have nothing in it, right? Because our right input is all possible days, and the left input is the days that had sales. So there shouldn't be existing any actual sales dates that aren't in our range. So this should be nothing for us. But the right output is what we care about. That's anything in our all possible days that did not match to actual sales. So let's run that and see what we get. All right, so we can see indeed that our left output does not have anything, and our right output has 22 records. So these are the days that did not have any sales. Okay, so now we need to figure out which day of the week those are. So I'm going to use a formula tool and connect it to that right output. And then I'm going to add a new column called day of the week. And I'm going to use date time format. So datetime format is kind of like the opposite of datetime parse that we used before. Datetime parse, the one that we used before, that takes a string and parses it to a datetime type based on the specifier string. Whereas datetime format that we're going to use now, that takes a datetime type and outputs it as a string according to the format that we specify. So we're going to take our sale date field and we're going to format it using the specifier %A, and that is the day of the week name. So we can see the preview here that it is for that first record is Saturday. And so again, that link to Alteryx help that I've put in the description below is going to be really helpful, because who would ever know that %A is the day of the week name. So now we have our day of the week name. And we just need to count up the number of days for each day of the week. So we'll use the summarize tool for that. And we'll group by day of the week and count the sale date. And the desired output says this needs to be called number of days. And then we'll output it. And I always encode mine with UTF-8, but or output mine with UTF-8 encoding, but that's just for consistency's sake. It doesn't really matter for this challenge. You can leave it with the default. All right, so let's run that so we can see our final output. So we have the expected 7 records, 1 for each day of the week, and let's sort this. So we can see that indeed Thursday and Sunday have the most days without any sales. So that's the solution for week 28. The one thing that I did want to add is we can see that we're sending all of those sales records. So our sales records have duplicates in it, right? So if I sort this by date, you can see I have 9 sales for January 1st, and I have multiple sales for January 2nd. So I'm sending a lot of unnecessary records into my join. So I'm sending all of my sales records, 4,063 of them, into my join, but I really only need to send the unique dates into my join. So really what I would do if I were doing this, for a production workflow, I would actually get rid of the duplicate dates. So you could either use a unique tool for this, or over on the preparation menu, a sample tool to just take the first record by date. Any of those would be fine. I'm going to use a summarize tool here, and we'll just do sale date, group by. And so we can run that. And so we can see that our output is exactly the same as it was. But this time, I'm only sending the unique day. So I'm only sending 1 record per day that actually had sales into my join. So that was 4,063 records before. Now it's only 343 records. So joins are pretty inefficient. So that's definitely a place where you can speed up your workflow by slimming down your data before you get into the join. So if this were a production workflow, or if I'm working with a large data set, I would definitely want to make sure I'm only sending the unique dates into my join. So there we have it, the Alteryx solution for week 28, and we'll move on to Python. All right, so let's start our Python solution by importing pandas. And then we have to input our data. So we'll do that with read CSV. And we're going to create a new data frame called df sales, and we're going to use read CSV to read the path to our input file. And this week I added some parameters here that we did not use last week. So first of all, we're using parse dates, and that takes a list of column names that you want to parse as dates. So in our case, it's just 1 column name, and that's sale date. The second parameter I'm using here is day first equals true. And so that tells pandas that our dates are in day, month, year format rather than month, day, year format. And then finally, the use calls parameter, I'm setting that takes a list of columns that you want to actually return into your data frame. And so in our case, we have 7 fields, I think, in the original data, but the only one I really want is the date. So I'm just going to tell use calls, just read in only the date column. So let's run that, and then we'll use info to take a look at it. So we can see the metadata about our data frame, df sales. We have 4,063 entries in our index, and we have only 1 column, and that's just the sale date column that we specified with use calls. And we can see that it has been correctly parsed to date time 64. All right, so we've got our data in, and it looks good. And we can see too that we have 4,063 non-null values, and that is good because that matches the number of entries that we have. All right, so now we need to process the data. So first of all, we need to get a list of all the possible dates. This is very similar to our generate rows tool in Alteryx. So pandas has a handy function called, or method called date range. So I'm going to use pd.date_range. And so we need to give it a starting point, and an ending point, and a frequency. And there are lots of other parameters we can use, but these are the ones we're going to use for this exercise. So my starting point is going to be the unique values the minimum value in my sale date column. So I'm going to say df sales, sale date, .min. So that's just going to take the sale date column and bring me back the minimum value in it. So for the end point, I'm just going to copy and paste that and change the min to max. So that's just going to give me the maximum value in that column. And then for frequency, I'm going to use 1 day. So 1D. All right, so let's run that and see what we get. So we can see that outputs a datetime index, and it has basically an array of dates from January 1st, 2022 to December 31st, 2022, which is what we expect. So for my next part though, I need that's a date time index, and I need that to be a data frame. So I'm gonna create a new data frame called df_all, and I'm gonna set that equal to, I'm gonna use pd.dataframe. And then I'm just going to use the dictionary method where my key is the column name date, and then a colon, and then I'm creating a data frame with one column called date, and the values for the date column are the values from my date range. We'll just move these onto the next row, and then in the dictionary, and then in the data frame. All right, so if I run that, we can see what we get. So we can see now I have a data frame with one column in it called date, and it's got all the values from my date range from January 1st to December 31st. All right, so then the next thing I need to do is get the dates that are in df_all that are not in df sales. So first I'm going to create a mask. And so the mask is just going to be the records that I want to keep. So we want to take df_all, the date field, and we want to find out if it's in the list of dates that are in my sales. So I'm going to say .is in, and then my list of dates is going to be df sales sale date .unique. So this is just going to give me a list of unique dates in my sales. So I'm just going to run that, and you can see these are all the dates that exist in my sale date column. So these are all the dates that actually had sales. All right. So I'm taking my my date field in my all possible dates, and I'm checking to see if that is in the list of sales dates. And then I'm just going to put a tilde in front of all of this, because I don't want to know if it's in that list. I want to know if it's not in the list. So the tilde basically acts like not. So this is going to return all of my dates that are in df_all that are not in the sale date column. And so then I'm just going to return the remainder. So df missing equals df_all dot loc. And so we're just going to use loc to specify the locations that we want to keep. So we need to give it a list of rows and a list of columns. So the rows we want to keep are where the mask is true. The columns we want to keep are just the date column. That's the only column we have, and so I've put date in brackets. You can certainly use date without the brackets with location referencing. But in my case, I want to make sure this returns a data frame and not just a series. So if I put it inside brackets, it's basically a list that contains only one value. If I put it inside square brackets, that's going to return a data frame, which is what I want. So let's go ahead and run that. So we'll run our mask, and we'll run our missing. And so if we look at our new data frame that we just created, the df missing, now it's just the list of the 22 dates that did not have sales. So just to go over that again, we created a mask that has the list of dates that exist in our all possible dates that are not in the dates that had sales. And then we said, okay, let's create a new data frame called df missing, and we'll set that equal to the all possible dates data frame where the dates are missing, and then the column is date. And that gives us our missing dates. So then finally, we need to get our list. We need to count up our dates by the day of the week. So let's get the weekday name first. So we're going to take our new data frame DF missing, and we're going to add a new field called day of the week. And then that is going to be equal to the date column from DF missing, the date accessor, and then day name. So handy, Pandas actually has a nice little function that outputs the day name associated with the date. So day name is the day of the week name. So if we run that, we can look at this, our DF missing data frame, and we can see now that we have the day of the week name for each of our dates. So finally, we need to aggregate. So we just need to get the count by day of week name. So I'm going to create a new data frame called df out. I'm going to set that equal to, first of all, we're going to need to chain a few things together. So I'm going to put this inside parentheses so that I can have freedom over the spacing inside. So the first thing I'm going to use is value counts. So this is handy when you're trying to explore your data and you want to understand what's in it. So I'm going to take my DF missing data frame, and I'm going to take that day of the week column, which is the day of the week name, and then dot value counts. So what value counts does is it outputs the day of the week, or whatever column you specify, it will count the number of occurrences. So if we run that, we can see we've got the day of the week and then the number of occurrences for each one. So now the problem here is that this day of the week is currently the index. This is a series where the index is the day of the week name and the value is the count. So we actually need these to be two columns of data with names so that we can output them. So I'm going to chain some additional things here. So I'm going to first chain on dot reset index. So what that does is it takes the current index and makes it a column of data, and then it creates a brand new sequential numeric index. So let's just run that so we can see what that looks like. So now you can see our day of the week name is in a column called index, and then we've got our values called day of the week. All right, so we're getting close, but the problem is in the output we're trying to recreate, the day of the week name column, which is currently called index, needs to be called day of the week. And then our count column, which is currently called day of the week, needs to be called number of days. So we'll just chain on rename columns. So I'm just going to chain on dot rename, and this is called pandas method chaining. So you can just add dot and then whatever method you want to add, and just keep on adding them so it will all kind of run together. So now we're going to add dot rename, and we're going to rename columns, and then we're going to use a dictionary to rename. So but renaming using a dictionary, your keys of your dictionary are the old column name, and then the values are the new column name. So this is just going to take the current day of the week column and rename that number of days, and it's going to take the current index column and rename that day of the week. So now if we run that, we can see that we have the data frame that we are looking for, with day of the week being the day of the week name and number of days being the count. So we are ready to output. So this is a simple output. We just take our new data frame that we created, df out, and then we use toCSV, and then the path to output. And then as usual, we're using index equals false because we don't want to output the index column. Now our index column is the sequential number. So there we have it, the solution to Preppin Data week 28 in Python using pandas. So if you want to keep watching, I'll show you the non-pandas method that I used. This is more of just a self-indulgence of trying new things. I think the pandas method is what I would use in practice, especially if my data set is small enough to do this. It's certainly a lot more readable and simple, but I had heard about sets in Python and I wanted to give those a shot. And I also, I just happened to see a post on Twitter about using collections, using a counter object from collections. And so I wanted to try that out. So We'll start just as we did before with inputting our data. So this is exactly as we did above in the pandas method. So we're just using read CSV to read into a data frame, df sales. So the difference here is I'm going to use sets. So let me go ahead and copy this date range. So I'm going to use this exact same date range that we built up here in our pandas solution. So I'm just going to copy that and paste it down here. Really, what we're doing here is set operations, right? We have one set of dates and we have another set of dates, and we need to figure out what's the difference between them. And so that just seemed like a good opportunity to use sets within Python. So I'm going to create my result called missing. And that's going to be equal to the set of all possible days, which is going to be my date range. Just line this up. And the one thing that I need to do is remember that the output from the date range is a range index, and I actually just need the values from that. So I'm going to do dot values and then wrap that in set. So that's just going to create a set of all of those dates. And then I'm going to subtract from that another set. So I'm going to create a set out of all possible dates that exist in my sales. So I'm going to use df sales, sale date, dot unique, which is all of the unique values in my actual sales. So I'm taking my set of all possible dates and subtracting from that the set of dates that actually had sales. And then I'm just going to wrap this in list so that my output is a list. All right, so we'll run that and then see what our missing list is. So you can see I have a list of NumPy datetime 64 objects, which are the 22 dates that are missing sales. All right, so now I've got my days without sales. Now I need to get the days of the week. So unfortunately, now that I'm outside of pandas, I don't have a nice, convenient way to get the day of the week name. And this is something that I tried a lot of different ways to do this. And the way that I did it is not elegant. I don't really like this solution. So I would love to hear if you have easier ways to do this. But so I thought I could do something like, let's see, I'll just create a new list called weekdays. And that's going to be equal to, say, a list comprehension of, so for every date in missing, I'm going to return, say, d.datename. Now, this doesn't actually work. This is just pseudocode, but this is what I was hoping that I could do something like this. But that doesn't actually work. So I looked, I said, well, for a Python datetime object, I know there are all kinds of functions that I can use to extract day parts, but there isn't one for the weekday name. There's one for weekday or ISO weekday that gives us the numerical day of the week, 0 through 6, but that's not really what I want. So I thought, well, datetime also has a depending on how you pronounced it, string format time or stirf time, that would let me format a date object in a specified format. So I could just format it as the specifier %A to output the day of week name. But it's really difficult. I couldn't figure out an elegant way to get from this NumPy datetime 64 object type to a datetime object type. So first of all, I'm going to need to import. First, we'll import counter. We'll import datetime, and we'll import datetime 64. We'll use counter later, but we're going to use the datetimes now. So then I said, well, okay. So let me just take D, which is my date in missing, and I'll convert that. I'll just use as type, date time, because I've imported that. And then I can use, once it's a date time type, then I can use stirf time or string format time. to convert it to the day of week name, which is the specifier for that is %A. And again, in the description for this video, I've linked a really helpful reference. It's from the Alteryx help, but it just has a list of different date specifiers and what they mean, because who would know that %A is the day of the week name? But anyway, so I was hoping this would work, and actually it doesn't, because so the type of datetime64 that I have right now has this time component in it, and I can't directly convert that to a datetime type. So I have to do another conversion first. So I have to do datetime64 and then convert my date to a D type of datetime64. And so the D just represents the date part only and without the time. So I need to take my day and let's just, I'm just going to copy this list comprehension and just do this first part. So we'll get rid of all of this. So what this is going to do is it's just going to cycle through all of the dates in my missing list. So for each D in missing, I'm going to take that D and convert it to a different flavor of datetime64, which is just the date part. So you can see what I have now is a date with time component. So if I run this list comprehension, I get something very similar, but it's just the date part. So then if I take that and do as type datetime and run that, now I have a list of Python datetime types. And now I can add start time. And if I run that, now I get a list of days of the week, which is what I need. All right, so that is going to be my weekdays list. So we'll run that so we can get that into weekdays. And so then I need to get the count by day of the week. So again, I'm still outside pandas, so I can't do like a group by or anything here. This is where I just wanted to experiment with counter. And so counter outputs a dictionary-like object that looks a lot like what we got from value counts when we did the pandas method. So I'm just going to create a new variable called weekday counts, and that's going to be equal to the output of this counter. So let's run that and see what that looks like. So that just gives us a dictionary-like object that has the keys are the days of the week, and the values are the counts. And so we can see the Thursday count is 6 and Sunday count is 5 as we expected. All right, so good. I have my counts now, but now I got to get them out into a file. So I just did this the old-fashioned way. Just open up a CSV file, just open up a text file and write to it. So I'm going to use a context manager here, just so I don't have to worry about remembering to close my file afterward. So I'm saying with, I'm just opening up a with block with, I'm going to open this file, this path, this is my output file, and I'm going to open it in write mode, and then I'm going to call that open file F. So once I have that file open, the first thing I'm going to do is write out my headings. So I'm going to take that file that I just opened, F, and I'm going to use .write, and that's just going to write a single line to my file. So I'm going to write day of the week, comma, number of days, and then a line break. And so that's my header row. Then I need to write out my data. So I'm just going to write it line by line. I only have 7 lines to write. So I'm going to use the list comprehension for that. So I'm just going to say f.write my values for KB in weekday counts dot items. So remember, weekday counts is this counter object, and that is a dictionary-like object with the days of the week as keys and the counts as values. So I'm saying cycle through all of the items in weekday counts, and that's going to give me a key and a value for each each set here. So for each key and value, I want to write those to a line. So I'm going to use an F string here. So I'm going to first write the key, which is the day of the week, and then a comma, and then the value, and then a new line. And so again, F strings in Python, you prefix those with an F, and it just takes whatever's inside the curly brackets, it evaluates that, and then replaces it with the value. So it's going to cycle through each one of these entries in my counter. And when it gets to the first one, K is going to be Saturday and V is going to be 4. So this is just going to write out Saturday, comma, 4, new line. And then the next time it cycles through, it's going to be Monday 3. So K equals Monday, 3 equals, or V equals 3. So then it's going to write out Monday, comma, 3, new line. And so it'll do that until it gets to the end Wednesday, and it'll write that out, and then it will close the file. So that is the bonus non-pandas solution for week 28. So I did do some performance testing on the pandas versus sets method. So the pandas method, I blew up the data, the original data set. It's only about 4,000 records, so I blew it up to about 1 million records. And the pandas method took 26.1, or an average of 26.1 milliseconds for that larger data set, whereas the sets method was a little bit faster at 19.1 milliseconds. So I think if I were going to do this in a real life application, I would probably choose the pandas method because I think it's much more readable. And for most data pipelining uses, the difference is going to be pretty negligible. So for that particular use case, for a data prep use case, I would probably use the pandas method just because it's a little bit easier to interpret. So there we have it, week 28 in Alteryx and Python. So once you finish your solution, please do share it with the rest of the Preppin Data community. If you participate in Tableau Prep, there is a forum in the Tableau community that you can participate in. And then if you use other tools like I do, such as Alteryx, Python, SQL, so have you, you can share on Twitter and GitHub. So if you go to the bottom of the Preppin Data blog post, they'll have the particulars, including the hashtag to use and anybody to tag in your post. And currently the hashtag is Preppin Data with no G. So please do share your results. You can also fill out the challenge tracker, which lets you keep track of which weeks you completed, and then you can also give feedback on how hard you thought the challenge was. So please do share your solutions if you feel comfortable. All of that's totally optional, but it's really great to know who else is participating and what tools they're using. And especially if you participate in Alteryx and Python, I love looking at everyone's solutions so that I can learn, because I always learn new things. There's always so many ways to go about this. So love to see you out there, and we'll see you next week for week 29.